Hey everybody, Mr. Burrell here, and we're going to talk about perimeters right now. So just to recap where we've been during this last couple of weeks is we started out reviewing the areas of different shapes, and then we kind of used our knowledge of areas to discover the Pythagorean Theorem, which told us how to find the side lengths of triangles. And then we used our knowledge of the Pythagorean Theorem to find the distance between 2 points using the Pythagorean Theorem. And now we're kind of coming back to shapes to finish this up and to talk about perimeters of shapes. So, question 1, explain in your words what a perimeter is. Well, let me tell you my words, and I'll let you write down whatever you need to in your own words. So, the perimeter is a measurement of the length around an object. So it's kind of like, yeah, that's it. It's just a measurement of the outside distance or length of a shape. Question 2, how is the perimeter of a shape different than the area? Well, there's like 2 things that are really important to mention here. The first thing is that a perimeter is a length. So like you can use, for example, I kind of tell my students in class, I say that it's a one-dimensional thing, meaning you could use a string to measure the outside of an object. And I just mentioned the second thing. So perimeter is a length measurement of the outside of an object. And an example of something you could use to measure that is a string. The area is like a 2-dimensional measurement, meaning you can't use a string to measure area. It wouldn't hold any meaning. It doesn't make sense. You have to use something more like a tile. Like you could think of the tile of a floor as being a way you could measure area. It's 2-dimensional. And it's the inside of a shape. So again, the perimeter is the outside of a shape. Area is the inside. And the perimeter is a length measurement where the area is like, it's not a length measurement, it's like a tile measurement. It's like a square measurement. Okay? So put those into your own words and you'll do great. Okay, now you're going to recognize all of these same shapes from our area homework. So, I don't know, you may go back to your area homework or not. I don't know, it's totally up to you. But this time, instead of counting the number of squares on the inside here, like we were doing when we talked about area, now we want to know the length of the outside of this shape. So, for example, here, the length is 4. And 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 so if I wanted to know the total length of the outside of this area, of this shape, I would just add all of those together. We'd do 4 plus 4 plus 4 plus 4 is 16 units. Now, I know this is really tricky because if you're looking at homework 11.1, we ended up with 16 units squared. But notice how different these 2 things are. We got the same number, and that really was just a fluke. It's something that happened, and it's something I did on purpose so I could talk about it in this video. But again, notice, I'm adding the 4 sides here to get a 16. In other words, if, let's say these were feet. We have 4 feet in blue, and 4 feet in red, and 4 feet in yellow, and 4 feet in green. We add all those together. I could have taken a string and wrapped it around the square, and if I unfold that string and measure it, it would be 16 feet long. Where before, when we were measuring area, we physically counted, I'm trying to get a different color here for us, we physically counted 16 of these squares on the inside. That's not something I could have measured with a string. That is only something I could have measured with these like tile-like measurements. Okay? So, if you remember back in homework 11.1, the area of this here was, I think it was 20. We had 20 squares inside of here. Now, let's go through and calculate the perimeter. Well, I've got a distance of 4 here, and I've got a distance of 4 here. And I've got, it looks like 5 across the bottom and a length of 5 on top. So when I add all of those numbers together, I end up with a total perimeter of, let's see, 4 plus 4 plus 5 plus 5. So that would be 8 plus 10, 18 units in length. Not square units, because we're not talking about the tiles. This is just normal units of length that we're talking about here. And 18 is not the same as 20. Okay, now again, just to juxtapose it, question 5, I believe, 5, 12, I believe we ended up with a total of 16. We got like an area of 16 on the inside. And that is not what we're going to get here. So, looking at the bottom, we have a length of 4. Looking at this side, we have a length of 6. Now, we need to figure out how long this side is right here to add it to the 10 units of length that we've already got. And to figure that out, I need to use the Pythagorean Theorem. I need to say, hey, there's my A, there's my B. So 4 squared plus 6 squared is going to equal C squared. I'm going to call that C. Okay? And so 16 plus 36 is going to equal C squared. So that's 52 equals C squared. And now I need to take the square root. So C equals the square root of 52. Well, I want to add that to the other shape, so why don't I just go ahead and approximate that already. So I'm doing it in my calculator right now. So, oh my gosh, I'm pushing crazy buttons. Okay, so square root of 52, that side is about 7.21. Now I can add 7.21 and 4 and 6. And that's going to tell me that the perimeter is about 17.21 units long. Alright? Oh, I know that's tough. This is a really tough unit. I know it. Okay. So, the perimeter. Let me give you a hint here. This is a square. So, whatever we decide one of these sides are, well, I can multiply that by 4 because all of these side lengths are the same. The way that I know that is they all share the same dimensions. These triangles are all the same. This is a 3 and a 4. This here is a 4 and a 3. And so, what I mean by that is this length here is going to be the same as this length because these lengths are coming from the same triangles. So, I've already started setting it up. Let me use some colors I've used in the past. I just need to find the length of one of these sides. So, 4 squared plus 3 squared is going to equal C squared. So 4 squared is 16 plus 3 squared is 9 equals C squared. And that means that 25 equals C squared. And let me take the square root. Take the square root. The square root of 25 is 5. So what I lost my colors. So 5 equals C. That's not my answer. What we just found was the length of this side right here is 5. And what I'm telling you is that these all, because this is a square, it's just tilted, all of these sides are also 5. So I could do 5 plus 5 plus 5 plus 5. If you want, that's totally great. Or you do 4 times 5 because there are 4 groups of 5. And so the perimeter of this crazy, turny square is 20 units. I believe on the area homework, we found out that the area was 25 units squared. So there was, like if we had redrawn the squares in a different way, turns out that there would be exactly 25 on the inside. But we weren't looking at the inside in this homework. We're looking at the outside of this homework. Okay, so let's come over here and talk about the perimeter of this triangle. This is something we found the area of before, but now we're finding the perimeter. Okay, this is pretty easy. Down here on the bottom, that's 6, which is great. But now we need to find the side length over here. Okay, so it looks like that's 6 tall and 2 wide. So let's use the Pythagorean Theorem. 6 squared plus 2 squared is going to equal c squared. So 36 plus 4 is going to equal c squared. And so that means that 40 is going to equal c squared. Now we'll take the square root, and it looks like we're probably going to have to estimate here, and let's do that. So the square root of 40 is about 6.32. So let me write that right here. That area, or that length, is 6.32. Okay, now let's find this other side length here. This is 4. This is 6. Just so that I have enough space to work, on the iPad I have to write bigger than normal. 4 squared plus 6 squared, because those are my legs of my right triangle that I just drew, is going to equal c squared. Oh, I meant to put that in a different blue. Morale. Okay, so 16 plus 36 equals c squared. And that means that 52 equals c squared. Let's take the square root. Oh, that says 52. It looks stupid though. And so in my calculator, the square root of 52 is about, this side length is about 7.21. Oh, hey, look. That was about the same that we got up there. It is the same. This triangle right here was the same dimensions as this triangle right here. Okay, so now what I need to do in my calculator is add this side length, and this side length together. So 6 plus 6.32 plus 7.21 is 19.53. That is about how long the outside of that shape is altogether. While you're here, let me just give you a little bit of hint, because I know this is so tough. This side length and this side length are going to be the same, and this side length and this side length are going to be the same as well. So hopefully that will save you half the time. Instead of having to find all 4 sides, you should be able to find 2 of the sides and maybe multiply that by 2. Okay. Oh my gosh, Morel, what were you thinking? First of all, I need to fix that. Okay. Like, look. This level needs to stop here, and this level needs to come down a little bit. Okay. Not important. So, let me help you out a little bit. Why don't I help you find this side length here, and this side length here, and then I'm going to leave the rest up to you. Okay. So if I wanted to find the length of that side, it's going to help me to make a triangle like this. So 3 squared plus 3 squared is going to equal c squared. So 9 plus 9 is going to equal c squared. So 18 is going to equal c squared. And so the length of this side is going to be the square root of 18. And let's approximate that. The square root of 18 is going to be 4.24. Okay? Down here, this is a little triangle. A 1 and a 2. Okay, so 2 squared plus 1 squared is going to equal c squared. So 4 plus 1 is going to equal c squared. So 5 is going to equal c squared. So we'll take the square root. I should have drawn that over here, sorry. C is going to equal the square root of 5. Square root of 5 equals about 2.23. So the length of that side right there is 2.23. Okay? And now I tried to give you lots and lots of space to work. You can use up here, you can use right here, whatever. But your goal is to find, you now need to find this side, this side, this side. Oh, that looks easy. And that side. Add all of those together and give me your perimeter. Okay, let me get you started on this question here. We already know that the perimeter is 21. So when I add all of these sides together, that's going to be 21 units. Now, why don't I write that out? I'm going to add x minus 6 plus negative 2x plus 23 plus x minus 3 plus negative 3x plus 32 plus 2x minus 15, and all of that added together is going to equal 21. So what you need to do is you've got to put together all of these like terms. So you're going to add all of your x's together and get some x number, and then you've got to add all of your constants together, and that's going to give you a number. And you got to set that equal to 21. Now, when all is said and done, that's going to tell you how much x equals. And you're not done there. We want to know how much each side length is. So from there, you want to plug in your x's into all of these different x's to figure out how long each side is. And then you're going to write your answers here. So find a number, find a number, find a number, find a number, find a number. Okay, that is this video. I hope that was enough help. If that was really confusing, I highly encourage you to just rewind the video and watch it one more time. Maybe pause before I finish something so that you can redo it yourself. Okay, again, I hope that helps. Make good choices today. Why don't you? And do a good turn daily. That would be so great. Okay, bye.